Dear students, we are in Closure Properties of Context-Free Language. I hope this term also is similar to you. We already learnt closure properties of regular language. The same concept here. Closure is when I merge whether it will work out or not. CFL or closure under union. What is that meaning? Sir, there is a language L1. It's a context-free language which is having context-free grammar. L2, it is also having context-free grammar. If I make it union, whether grammar exists. If it exists, it is closure. Okay. So L1 is obeying one VTPS rule. L2 is obeying one VTPS rule. For example, L1 is A power n, B power n. Its grammar is available here. Just have a look. AXB, that is A on both sides, A and B on both sides. So if you repeat, X you replace by XB, X you replace by XB. If you repeat 4 times and finally you remove X as epsilon, you will get A power n, B power n. Okay, already we discussed. One more language, C power K, D power K. The same rule, CYD. Y you replace CYD, CED like this you can do. Now, this is L1, this is L2. Can I have L1 union L2? If you can merge that, it is possible. Yes, see, all this blue color I made, all green color I made. I can have like this one rule, AX is also allowed, BX. Okay, you can have union. So, union of grammar is accepted means union of language is also accepted. Hence, it is closure. That's all. Let us go for concatenation. It is also closure. How? Take the same rules, grammar. Then you take the same example, A power n, B power n. One more, C power K, D power K. Now, if I can concatenate two grammar, I did concatenate. This is separate, I concatenate. If you could have concatenate two grammar, definitely you could have concatenate two languages also. Yes, sir, possible. Then it is closure under concatenation. That's all. Next, closure under star. What do you mean by star? Repeated any number of times. Now there is a language with grammar VTPS. Now I am showing you A power n. What is the rule to write down? AX, repeat X by AX, repeat X by AX, which is called A, 2A, 3A, 4A, 5A. Accepted. This is a language. Now beautiful. What is L star? Let us have 3A's. Okay. What is L star? This 3A should repeat. 3A, 6A, 9A. Sir, I no need of any rule, sir. This itself will work out. How come? You repeat the same. 3A, 4A, 5A like this. That's all you know. So 3A, 6A, 9A accepted. Now tell me. This is L. This is L star. This is L. This is L star. L grammar is here. L star grammar is also same. Which means it is closer under Kleene star. Next. Intersection is not closer. It is not allowed. Why? L1 you take with the grammar. L2 you take with the grammar. Now I am going to bring A power n, B power n, C power m. Purpose I am taking a different m value. Okay. Let it be. One more language I will take. For example, 2A, 2B, 3C. Because it is m. For example, I have taken. Another language I will take. A power n, B power m, C power m. Let us do that. 2A, 3B, 3C. 2A, 3B, 3C. This is n count 2, m count 3. Now, what is L1 intersection L2? Can I have common n term, common m term? We will try. Then intersection is L1, L2, which is common term count. If I take L1 intersection L2, it should be either A power n, B power n, C power n. That is like this, not satisfying. Or A power m, B power m, C power m, which is 3 letters, which is also not satisfying. Which means, sir, individually for this grammar is there, for this grammar is there. If I take a common count as an intersection, these two grammar will not work out. So, it is not in a CFL. So it is not a closure. That's all. Okay, this is the concept we are having. The fifth property is not closure under complement. Come on, recall your fourth property. It is intersection is not closure. Now complement is not closure. If L is a language, L bar is called complement. It is not allowed. Now I am going to prove this in a different way. How? De Morgan's law. What is your De Morgan's law says? If you have A intersection B, if you take its common bar, A bar, B bar, whole bar if you take, what is its De Morgan's law? Common bar become individual bar. Then A bar bar, B bar bar. What is A bar bar? A. B bar bar, B. As per De Morgan's law, if you do common bar become individual bar, union become intersection. That's all. Over. Okay, remember, keep this De Morgan's law aside. Now take a language. A bar, union B bar. Okay, there is a language. A bar, union B bar. Next. What is its L bar? Because I need its complement, What is its L bar? Union is closer, already we discussed. What is its L bar? What is that L bar? This whole thing I am going to give bar here. If I do bar, carefully tell me, as per De Morgan's law, what happened? This fellow is same as A intersection B. Therefore, L bar is nothing but, as per De Morgan's law, A intersection B. Now what is the conclusion? L is this person, L bar is this person, as per De Morgan's law. Union is closer, intersection is not closer based on property 4. So, L is context free, L bar need not be context free. So, complement is not a closure. Okay, we discussed 5 properties here. What are the 5 properties? Union, concatenation, star. All 3 are closure. Intersection, complement is not closure. With this, I would like to conclude this normal form. We discussed CNF, GNF, and we also discussed pumping lemma for context-free language and properties of context-free language. With this, I would like to conclude this particular video lecture. Thank you.